Hello YouTube, this is UML03. So I planned for this to be the very last video on the Python programming. I've been demonstrating my understanding of the Python concepts, and we've already explored a lot of cool things you can do in Python. In my opinion, it's a little bit easier to write code in Python than it is to write code in Java, and that's just kind of cool. Fundamentals can come a little bit more easily. So hopefully you've enjoyed either following along the entire way, which I hope that some people have done, or at least tuning in on the videos that you need the most help or support or find the most interesting. So anyway, what we're going to do 4 things in this video. So we're going to review keyword arguments, and then we're going to talk about 3 new topics. So 3 new topics, but 2 of them will go very quick. It's just kind of tying up some loose ends and teaching you as much as I possibly literally can about Python. Okay, so essentially what we'll do is we'll look again at this keyword function, and we said, remember that you can have concrete arguments that start at the beginning of the parentheses, right? So here A is a concrete argument, and you can have more than one. So you could have had A and D, okay? And so here D is an example of a variable that's not being used, right? But you could have gone ahead and used it. So here A and D are examples of 2 concrete inputs. So hopefully that's clear to you. And then here the star B, this is an example of a positional argument. So this is basically a collection of comma separated inputs. And we don't know how many comma separated inputs there are going to be, but it's okay, because we're just going to treat the whole collection of them as a tuple. We're just going to really process it. We're going to pretend that it's one argument coming in as a tuple. So hopefully that makes sense to you. And then we can also have star star C. So remember, if we do have these variable assignments, and if you call in a function where star star C is in the function header, and if the last few, the last 1 or 2 or 3 or 10, but it has to be the last, right? But so the last arguments are these variable assignments. So, winter is assigned to a tuple with 3 elements. So is spring. Basically, that means that those values are going to be parsed as though they were key value pairs in a dictionary. Okay, and so since there are 2 key value pairs here, that would be the length of C if you called keyword function with these particular inputs. So hopefully that's clear to you. And then I'm just going to go ahead and remove the D here. But the point is that you can have multiple concrete arguments before you have your positional arguments, before you have your keyword arguments. So these are called positional arguments with 1 star. They're just simple comma separated inputs. And these are called keyword arguments with 2 stars. And those are sort of these variable assignments that you're passing in at the end. So hopefully that's clear to you. And then you can run it with different types of inputs too. So you could have said keyword function. What if you had this set, right? So I think we said that this would actually return 14, I think, if I remember, right? Because you had 9 elements in the set. And then you had 2 comma separated inputs that you have here. And then you have 3 variable assignments. And then what if you have this one? So here you have basically a set, right? You have a set with just one unique element in it, just a 3, right? And then you just have 1 element that you're passing in. This list is just 1 element, 1 positional argument for this star B that you see up here. So it's going to be 1 as the length of this set, plus 1 as the, the length of the tuple, where tuple is just the elements, right? The tuple just has this 1 list in it. So it'd be 1 plus 1 plus the number of assignments that you made here, which is 7, or which is 5. So 1 plus 1 plus 5 is 7. So hopefully that's clear. And then there's other examples, but I think what we'll do at this point, so okay, real quick, so my func of S and star U and double star V, so you can call these whatever you want, but you would say my result is equal to S, and then my result is going to be added on, we're going to add on V of age, okay? So either V of age is some, list, and then S was a list, right? So we're concatenating 2 lists together. Maybe we're adding 2 numbers together. Maybe we're concatenating 2 strings together. It's a little unclear, but hopefully contextually it'll be clear eventually. And then plus, and then we're going to add on U of 3, right? So the 4th comma separated argument that came in after S, really technically the 5th argument that was passed into the function. So hopefully you can see why that's the case, right? And then so what we would do is we would just say, what if we just said X equals my func of this? So this is an example of a function that both prints and returns something. So by virtue of just making this function call, we print 0, right? But then hopefully we would be interested in seeing what the result of X would be. And then you could do the math here, right? It would be the 2, and then V of H would be 42, right? So 2 plus 42 is 44. And then we would subtract the 100. So hopefully you'd be looking at a negative 56 there. And indeed, that's what you get. We can also talk about something called tuple unpacking. So remember, we said basically that when we create a tuple, usually it's contained in parentheses, right? But we said also once or twice but you don't actually need those parentheses, and you can actually create a tuple just with comma separated values. So you could have said my tuple equals A, B, and C. You could have said something like that, but the point is that tuples can really just be created by these comma separated values. The point is that you can go the other way around too. So you can actually create comma separated variables by assigning them to the elements of a tuple. And you would have to have the number of variables align with the size of your tuple, okay? So if you said A, B, C is equal to some tuple, then the tuple needs to have 3 elements in it. If you say A, B, C, D, E, F is equal to some tuple, then the tuple needs to have 6 elements in it, right? But that's essentially something you can do. So I'll show you a quick example here. Basically, we have my tuple is equal to 4301. I'm going to remove the parentheses just to remind you that tuples can be created without them. And then you could say A, B, C, D is equal to my tuples. This is called tuple unpacking, tuple unpacking. And it's pretty simple here. And then we also, remember, we also said that you can do a variable reassignment. So you could have said something like A comma B equals B comma A, and that would swap the values of A and B. Well, it turns out you can do that for multiple values. So basically what this does is it reassigns A to D, B to C, C to B, and D to A. Okay, so hopefully that's clear to you. And it'll keep track of all those assignments, right? And then we can go ahead and clump the my tuple back together. So my tuple equals A, B, C, D. And so now if we go ahead and see and try to print the tuple, you can see that the values have been swapped. So hopefully that shows you how tuple unpacking works. It's pretty simple, but it's nice to know or to be reminded that it's available to you. We also have something called the ternary operator. So remember when we talked about Booleans, we talked about if-else logic, right? And we talked about if blocks. And so we have a Boolean, right? Like if some Boolean A is true, do something. Otherwise, do something else. That means, you know, if A is true, if this Boolean is true, we'll do this code and not the else code. If the A Boolean is false, we will not do the do something code. We will only do the do something else code. So hopefully that's clear to you. It turns out that there's actually a much more compact way to write all of that. So we can actually just write do something if A, else do something else. So it's sort of like a lambda function, right? It's sort of just like collapsing all this architecture into one line, right? And so instead of writing if A, do something, else do something else, just write do something if A, else do something else, right? It's just one line. It's just one line. And so we can see an example of that. Let's go ahead and see an example. What I do, well, this was the old-fashioned implementation, right? So you could have said B equals false. If B, A equals 20. Otherwise, A equals 30, right? And then you could go ahead and print A down here. You could print A, and then hopefully we would expect to get 30 down here, right? But then you can do the same logic, right? You can see I have two 30s because one of them was coming from this old-fashioned if-else logic. And then this one comes from what's called the ternary operator. It's called the ternary operator. And it allows you to just basically collapse the if-else block into a very, very simple one-liner. So you would just say C equals 20 if D, else 30. Okay, and so hopefully that, and it's basically else, otherwise it's a ternary operator. So this is a compact way of writing an if-else statement. And notice that, so this is particularly well suited to assign the value of a variable, right? Because what you would do is you would say assign, so you would say assign value to some variable if Boolean is true, else other value, assign variable to some value if Boolean is true, otherwise other value, right? And this is the notation. You don't even have to say C equals again. In fact, it might even create an error if you tried writing that. Maybe not, but you could just write else 30, right? Else 30, and this is really compact. It's like 5 words instead of having to write all these different lines. Okay, so hopefully that's clear to you. And then this would just be 2 different ways of doing the same thing. So now if you say print of C, it would print 30 because C was reassigned to 30, so was assigned to 30 instead of 20 since the Boolean was false. We can also talk about something called else, okay? And we've already talked about else, but we've done it in the context of if else, right? That's what we've been talking about for the past couple of minutes, right? Else is the code that runs if and only if the Boolean that the if block was checking was not true, right? If and else logic allows you to run exactly one block of code. The first block of code if the Boolean's true and not the second, right? The first block of code and not the second block of code if the Boolean was true. Not the first block of code and the second block of code if the Boolean was false. There's another use of else, and it actually happens in the context of exceptions. And so I'm going to link to my videos on exceptions in this video, but in the Java programming, exceptions was one of the last videos that I talked about. And so here it could also be one of the last videos that we talk about. It's called exceptions. And remember, it's a way of diverting the program, the run of the program, the execution of the code, if you foresee runtime errors happening. Okay, so what we're going to do is we could think about dividing by 0. Or we could think about indexing an array, you know, far beyond its length or something like that. Or we could think about calling on a variable that hasn't been initialized yet. So what if you just say print of x, but x hasn't taken a value yet? So what we can do is we can study this else architecture. And it's not that difficult. The way that it works is, remember that the way that we can actually review this try architecture here. So remember, we're going to try some code, right? We're going to try to run the try block. If it's completely successful, we skip the except block, right? So the except is going to call out a particular type of error, right? We talked about different types of errors, different types of exceptions, like index error, arithmetic error, value error, okay? Syntax error, okay? And so basically, if you can foresee and predict one of those errors, like an index error, for example, if you can call it out ahead of time, and if the program otherwise would have run a runtime error, instead of doing the runtime error, it'll just run this alternate code instead. It'll just say, oh, print, that didn't work, sorry. And it'll run as much of the try code as it can, but it'll stop at the point where there would have been an index error, and then it'll just go ahead and say this code instead. It stops the try block. It said, okay, I've done as much of the try block as I can until this exception appears, until this index error appears, right? And then it'll say that didn't work, sorry. And then remember that the finally code runs regardless. So regardless of whether or not the code runs an exception, the finally code will run, okay? So there's two cases. Either the try block ran successfully, in which case you run the try code and then the finally code, or the try block doesn't run successfully, in which case you run as much of the try block as you can, you catch the exception, you run the except code, and then you run the finally code, right? But then at that point, you didn't run the entire try block. The only way the except code runs is if the try code was at some point unsuccessful, okay? You couldn't run all of the try block and the except block, okay? So hopefully that's clear to you. But what the else does is, so basically the else will run if and only if the except does not run. Okay, that's the architecture here. So we'll try, assuming the run is successful, we don't run the except block, but we will run the else block. And then finally, we will run the finally block. So again, the finally code, 100% of the finally code executes 100% of the time. Okay, so that will always run regardless of what happens. Okay, and we will say that the else runs if and only if except does not run. So runs if and only if the try block was 100% successful. Okay, so hopefully that's clear to you. And then if it was, then you would go ahead and run else. If it was not, you cut off the try block at the point it was unsuccessful, and then you run the except code, and then you run the finally code. Okay, but in either case, you'll run the finally code. So the question is, do we do a successful run and then run all of else and then run all of finally? Or do we do a unsuccessful run, right? Maybe we get a little bit of the try block, but not all of it, in which case we would have to run the except code and not the else code, but then we do run the finally code. Okay, so that's the use of else when we're talking about exceptions. Okay, so we'll see a couple of examples. Let's do a couple of examples here. So we're going to try to start the summer. Okay, so we basically have a list. Okay, so we have a list with 3 strings in it, pretty straightforward. And so summer months is June, July, and August, right? In my opinion, those are the 3 months of summer. Okay, and then what we do is we convert it to a tuple. We're just going to reassign it to a tuple. So we're going to say summer months, I want you to take your current form of yourself and just convert yourself to a tuple. So now it's going to prevent the elements from being modified in any way. Now it's set in stone, June, July, and August. You're not adding to it. You're not removing from it. The only thing you can do is access elements by index position, count the number of occurrences, find the length, things like that. What we're going to try to do is print the line, going to try to start the summer, okay? And probably there's not going to be issues with printing a string. What there might be an issue with is printing an element, an element at a particular index position, because if that element were out of bounds, we might want to try to catch that exception and do something else instead of having a runtime error. But this is just going to print summer months of 0, so it prints the element at index position 0 within this list. So it's going to try to print June. And if there's no issues with that, then it's just going to go ahead and do these 2 lines of code and not run the index error code because there was no index error, right? But then it'll run the else code, right? Because since the except code doesn't run, the else code runs. So it'll say, woohoo, it actually worked, okay? And then it'll finally say, okay, we tried starting the summer, hopefully it worked, because the finally code doesn't know whether or not it worked, right? The else code knows whether or not, the try code was successful if the else code runs. But finally doesn't know, finally runs regardless. So now let's go ahead and run it. And it's going to say, going to try to start the summer, okay, and it prints June. There's no issue with printing an element at index position 0 within a list. Or I guess we're talking about a tuple now. Sorry, we've been talking about a tuple, right? We converted it to a tuple. But anyway, it prints the element at that index position within the tuple. So June, and then woohoo, it actually worked. And then, okay, we tried starting the summer. Hopefully it worked. Okay, so hopefully that's clear to you. What we're going to do now is we're going to uncomment that example. And we're going to do something very, very similar. I sort of wrote the same duplicate code twice, but instead what I'm going to do is instead of saying summer months of 0, we're going to try to say summer months of length of summer months, okay? And you can try to think about the indexing here. Remember, we said that the last valid index position of a list or a tuple is the length minus 1. Remember, you start at index position 0 and you go up to the length minus 1. The length is not included. So if you try to make the length of the tuple the index position, that's actually the first index position that's not valid, okay? So this would be an issue. And we could say something like, I'm going to try to end this summer, right? What if we wanted to try to print like August or September, but we wanted to try to get to the end of the summer, right? And so we would say length of summer months, right? Maybe we're trying to get August, right? Maybe we're naive, right? And we say, oh, it's at index position 3 because it's at the third element, right? And so I want because the length is 3, so I want the element at index position 3, but someone naively does is that, right? And so the index error is going to call it out, and it's going to print the first line in the try code. Remember, you have to remember that the try code runs as much as it can. It doesn't just completely skip if there's going to be an issue. So it says going to try to end the summer, and then it'll say that didn't work, sorry. And then it'll skip the else code because we said the else code runs if and only if the except code did not run. But here the except code would run because length of summer months is not a valid index position to summer months. Okay, and then you are going to run the finally code. Remember, the finally code runs regardless. And I guess in the IDE, if you hover over this stuff, the PyCharm, IDE will give you a whole lot of information. It might be a little bit more than you're interested in reading, right? But the try statement specifies exception handlers, and this is all the stuff that we've talked about in this video and in previous videos. And I don't know if they're actually going to talk about else here. It looks like they just talk about try and finally, but hopefully you're getting a sense of what else means, right? And maybe if we hover over the else word. So else, no, maybe not. So yeah, I can't really come up with too much else to say about these things. Hopefully all this is clear to you. This is just tuple unpacking. I don't know how much else we can say about this. I can try to fill up this video to 20 minutes, but I mean, these are, keyword arguments, and then, just like a tuple can be created by comma separated values, comma separated variables can be automatically assigned from a tuple. So it goes in both directions. You can create a tuple from the comma values. You can create comma values from a tuple. That's called tuple unpacking. Instead of packing up a tuple, you're unpacking it. And then finally, it says, and then ternary operator, right? So instead of assigning a variable just by saying, if some Boolean is true, make x equals something, or otherwise make x equals something else. You could have just said x equals something if the Boolean is true, otherwise something else, right? And you don't even have to say x equals twice. You can just say it once. And then finally, we talked about the else statement, the idea that the else code will run if and only if the except code did not run, if and only if the try code was completely successful. So hopefully that's clear to you. Hopefully those were interesting concepts to you and that you enjoyed studying the Python curriculum. I don't know if I'm going to make more videos. Maybe I'll go on and do some more C++ or C# if I get a little bit more free time. But I moved to Phoenix, Arizona recently, and I'm hoping to explore the area and not be cooped up inside too much. But take some time being cooped up inside to try out all these programming fundamentals that we've tried out throughout the course of these 46 videos. From UMills03, thanks for watching, and please subscribe.